The forgotten dwarf planet, Ceres. Definition of Ceres. Is Pluto the only dwarf in our solar system? Deep in the space hidden from our eyes lies a planet whose surface temperature reaches a whopping maximum of 180 Kelvin and as low as 240 Kelvin. Yes, we are talking about the forgotten dwarf, the largest object in the asteroid belt lying between Mars and Jupiter. Named after the Roman goddess of agriculture and discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is a perfectly spherical body despite being bombarded by thousands of tiny asteroids daily. It has been in discussion among scientists recently, as many believe Ceres is our best occupancy option. Ceres is believed to be the least geologically active body in the solar system, with no evidence of volcanism, tectonic activity, or significant erosion. It has a low density and a low gravitational field, and its surface is covered in impact craters, suggesting that it has been relatively inactive for billions of years. Overview of Ceres. Dwarf planet is a designation given to celestial bodies that are too small to be considered full-size planets, but have enough mass and gravity to be nearly round. Being the most massive object in the asteroid belt, it is also the first object in the asteroid belt to be classified as a dwarf planet. Ceres is the only dwarf planet in the inner solar system. Its surface is covered in impact craters, with some smooth areas that may have been caused due to cryovolcanism. Due to constant volcanic activities on the planet, the surface appears shiny and dark when observed through telescopes. Ceres was formed 4.6 billion years ago, shortly after the formation of the solar system. It is believed that it formed from the same material that came together to form the other planets, moons, and asteroids in the region. The formation of Ceres was likely aided by the gravitational pull of Jupiter and Saturn, which caused the material in the asteroid belt to coalesce and form into the objects that exist today. Size and mass. One of the striking features of Ceres is its colossal size compared to other objects in the belt. At 590 miles in diameter, it is the largest object in the asteroid belt and roughly the same size as the state of Texas. Ceres is also much denser than most asteroids, with a mass of about 9 quintillion tons, about a third of the entire asteroid belt's mass. Ceres is not a solid rocky planet like Earth or Mars, despite its size and density. Instead, it is believed to be composed mainly of water ice, with a rocky core and a thin, dusty mantle. It is because Ceres has a surface temperature of about 180 Kelvin, which is too cold for liquid water to exist. The water on Ceres is considered frozen solid, making it a water world in the same sense as Europa and Enceladus, two of Jupiter's moons that are also considered to have large amounts of water ice beneath their surfaces. Surface features of Ceres. In 2015, NASA's Dawn spacecraft arrived at Ceres and began studying the dwarf planet in detail. The spacecraft found that the dwarf planet has two distinct types of terrain, one that is heavily cratered and one that is relatively smooth. The smooth terrain is thought to be the result of recent geological activity, possibly due to the presence of a subsurface ocean. The spacecraft also found that Ceres has a surprisingly diverse surface, with various geological features such as mountains, craters, and plains. One of the most fascinating features of Ceres is a series of bright, reflective spots discovered on its surface. These spots, which were thought to be salt deposits, are concentrated in a region called Oort Crater, which is about 60 miles wide. Scientists believe that the bright spot may be the result of saline water that was spewed out by a meteor impact and that the water froze and left behind the salt deposits. Ceres is also home to some of the fascinating geological structures found in the solar system. One, the Oort Crater, is a massive impact crater located near the center of Ceres, measuring about 90 kilometers in diameter. 2. Haumea Mons. Ceres is also home to one of the largest mountains in our solar system relative to its size. This mountain, called Haumea Mons, is about 13,000 feet or 4,000 meters tall, and is thought to be a cryovolcano or a volcano that erupts with water, ammonia, or other volatile substances rather than molten rock. Due to a large number of water resources on Ceres, it has always been a topic of discussion among scientists. Some scientists even believe that Ceres may be the perfect resource storage for us to be used in the future during interstellar travel. indeed owing to the large reserves of water present on this planet, which may be mined in the near future. Ceres has been studied extensively over the past few decades, and scientists have learned a great deal about its characteristics, composition, and geological history. Internal structure. Ceres has a differentiated internal structure consisting of a silicate-rich crust, a mantle of ice and volatile compounds, and a core composed of a mixture of rocky materials and ice. The crust is estimated to be around 30 to 40 kilometers thick, while the mantle is believed to be at least several hundred miles wide. The core is thought to be roughly 200 kilometers in diameter and may contain up to 30% of ice by mass. Some scientists believe that Ceres may contain clues about the early solar system, as Ceres and other objects in the asteroid belt are the remnants of the solar system's building blocks. Surface composition. The surface of Ceres consists primarily of a mixture of water ice, silicate rock, and organic compounds. The exact composition of Ceres' surface varies across its surface, with some regions having a higher percentage of the water ice component. In comparison, others may have a higher rate of the silicate rock component. The organic compounds are mainly associated with a variety of craters, suggesting that they were delivered to the surface through asteroid impacts. The surface of Ceres is also believed to contain a variety of salts and other volatile materials, including carbonates, sulfates, and nitrogen-bearing compounds. These materials are thought to have been delivered to the surface over time by comet and asteroid impacts. The Dawn spacecraft played a vital role in the determination of geological conditions on Ceres. Had it not been launched, you wouldn't be watching this video. The spacecraft conducted a detailed study of Ceres and its environment, allowing scientists to understand better the dwarf planet's geology, composition, and history. The Dawn mission revealed Ceres' weak atmosphere, primarily water vapor. In addition, Dawn was the one to find evidence of ice on the surface of Ceres, suggesting that the dwarf planet may contain a subsurface ocean of liquid water. Recent observations from the Herschel Space Observatory have confirmed this possibility. The Dawn mission also allowed scientists to map the surface of Ceres in detail. In addition to the Dawn mission, other spacecraft have visited the dwarf planet. In 2018, the European Space Agency's Rosetta mission conducted a flyby of Ceres, allowing scientists to make detailed observations of the dwarf planet's surface. Ceres continues to be one of the fascinating objects in the solar system, and scientists are sure to learn more as new missions are launched to study it. Ceres is an intriguing and fascinating body, and is the only dwarf planet in the inner solar system. Its unique characteristics and geological history make it an important target for further study. With the help of spacecraft like Dawn, we can continue to learn more about this mysterious world. Despite this, its exact origin and history are still largely unknown. Efforts are being made as we speak to have a complete overlook on Ceres. It may not be a while, but soon we may have significant knowledge about Ceres to specify its significance to humans. Overall, Ceres is an essential object in the solar system due to its size and composition. Its existence has helped to shape our understanding of the solar system and its formation. Pluto's classification might get revised again. In 1930, a famous Disney cartoon character named Pluto made its debut. Coincidentally, that same year, astronomer Clyde Tombaugh made a significant discovery in the solar system, a celestial object that would later be named Pluto. Some argue that the animated dog was named after the newly found planet to capitalize on its popularity, but the true reason remains uncertain. What is certain is that both Pluto, the character, and Pluto, the small planet, have continued to captivate astronomers and the public alike since their respective discoveries. From the start, astronomers faced difficulties in classifying Pluto. The question of whether it should be considered a planet or dwarf planet has persisted over the years. Recently, the discovery of one of Pluto's moons, Charon, has once again sparked discussions about its classification. Some propose that the Pluto-Charon system should be classified as a binary dwarf planet system. This classification would recognize the interconnected nature of the two bodies, emphasizing their shared characteristics and dynamics. But it's not that easy. Pluto. So back in 1930, big things were happening in the field of astronomy. They were making all kinds of advancements and discovering some pretty cool stuff. One of the most interesting finds happened at the Lowell Observatory in Arizona. They noticed this little dot of light that ended up being the 9th planet in our solar system, Pluto. Before we get into all the details, we have to give a shout out to Percival Lowell. He was a really smart astronomer who spent his whole life studying the outer parts of our solar system. He noticed that Uranus and Neptune had these weird orbits, and he thought it was because of another planet out there. Lowell did a ton of observations and calculations and came up with the idea of a 9th planet, which he called Planet X. Even though Lowell died in 1916, other astronomers at the Lowell Observatory carried on his work. This is where Clyde Tombaugh comes in. He was a regular guy from Kansas who loved looking at the stars. In 1929, he got a job at the Lowell Observatory taking pictures of the night sky. His job was to carefully compare the images and see if anything was moving out there. It was a lot of work with lots of late nights and close examination of these pictures. But after almost a year, Tombaugh hit the jackpot on February 18, 1930. There, in a couple of pictures he took in January, he saw this little dot that had moved from its original spot. That little dot was our friend Pluto, finally discovered. Now, even though everyone was excited about finding the 9th planet, some scientists weren't sure if Pluto really fit in the same group as the big gas planets. It was pretty tiny and had a weird orbit. This debate went on for a long time until finally in 2006, they decided to call Pluto a dwarf planet instead. Before that, nobody had ever heard of a dwarf planet. What was that? An official definition was required, a definition to distinguish between a planet and a dwarf one. Charon. The honor of discovering Charon falls to Dr. James Christie, an astronomer at the United States Naval Observatory. In June of 1978, while conducting observations of Pluto, Christie noticed a peculiar elongation in the planet's shape. That was Charon. The revelation of this moon's existence brought about a fundamental shift in our understanding of Pluto's true nature. Charon is a substantial moon with a diameter roughly half that of Pluto. The size relationship is unparalleled in our solar system, and this is one of the main reasons why astronomers might want to reconsider the classification of this system. It turns out that Charon has a huge canyon system that stretches along its equator. Its total length is at least 1,000 kilometers, and its depth reaches 5.6 miles or 9 kilometers. Just for comparison, the Grand Canyon is only 1 mile deep. This was discovered by NASA's New Horizons mission, a spacecraft that made history with the first close-up exploration of the Pluto system. One of the most significant aspects of Charon's discovery is its impact on the Pluto-Charon system's center of mass, known as the barycenter. This is a point around which a system composed of two objects rotates. If one of the two objects is by far the heaviest, as in the case of the Sun and the Earth, or Jupiter and its moon Io, the barycenter falls directly inside the heaviest object's radius. This means that although the Sun certainly feels the effect of Earth's gravitational pull, its shift along the orbit is kind of negligible compared to how much the Earth moves due to the Sun's pull. The same applies to Jupiter and Io, but this is not always the case. If the two objects have a comparable mass, then the barycenter can fall outside of the most massive body, and both objects can move effectively around that point. This is exactly the case of Pluto and Charon. The barycenter of this system lies outside of Pluto, in the space between them. This unique configuration has far-reaching implications for the orbital dynamics and mutual interactions of these two celestial bodies. In other words, we can confidently say that the Moon orbits the Earth and that Io orbits Jupiter. But while it doesn't seem 100% correct to say that Charon orbits Pluto, or at least it does it in a different way. One thing is certain, if Charon does not properly orbit Pluto, then it's not Pluto's moon. Moreover, Charon orbits around the Sun. It is spherical in shape and it has not cleared its neighborhood. Therefore, it seems to meet all the criteria to be considered a dwarf planet. If that is the case, then the Pluto-Charon system has to be regarded as the first binary dwarf system in the solar system. At this point, a question naturally arises. Is it possible to find binary planet systems anywhere else in the universe? Double planets' existence. Well, it depends on the labels we give. While the definition of a binary planet system varies, there has yet to be any discovery of two planets revolving around a common center of mass. However, if we broaden the definition of a planet, there are instances where two bodies are much closer in mass. One prominent example is the Earth-Moon system. Although the Moon is not typically considered a planet, its mass is approximately 1/81th that of the Earth, making it the largest satellite relative to the size of its primary. The European Space Agency has even referred to the Earth-Moon system as a double planet. While this system may not fulfill the criteria of a binary system, it highlights the possibility of bodies without similar mass ratios. The Pluto-Charon system, with its mass ratio of about 1:8, closely approximates a binary system. However, due to debates surrounding Pluto's planetary status, this system is now often referred to as a binary dwarf planets system. Nonetheless, it serves as another example of bodies with comparable masses. Additionally, there are binary minor planets such as 90 Antiope, where the two bodies are nearly identical in size. This finding showcases the existence of minor bodies that can be considered binary. While we have not yet discovered binary planets in the strictest sense, the presence of binary-like systems such as the Earth-Moon and Pluto-Charon systems suggests that they may exist elsewhere in the universe. After all, binary star systems are very well known in the universe. It's actually estimated that up to 85% of stars are in binary systems, with some in triple or even higher multiple systems. In these terms, our Sun seems to be one of a kind. However, even though binary stars are very common, double planets are expected to be much rarer because their formation requires specific conditions and a delicate balance of gravitational forces. However, there might be some good news. The recent discovery by the JWST in the Orion Nebula has identified approximately 40 pairs of free-floating gas giant planets. These unique findings, known as Jupiter-mass binary objects or jumbos, have surprised scientists as they appear to exist as couples. The intriguing question remains unanswered. Did these jumbos originate from the gas in the Orion Nebula as failed stars, or were they captured from a different planetary system through the gravitational pull of a passing star that disrupted their orbits? Further studies and observations will shed light on this mystery in the next couple of months. Stay tuned. Understanding these systems will contribute to our knowledge of celestial mechanics and the formation of planetary bodies. Eris, the Forgotten Planet. When Michael Brown announced on February 28, 2004, the discovery of Sedna, an object believed to be nearly 2,000 kilometers large, orbiting between the Kuiper belt and the innermost part of the Oort Cloud, it seemed to everyone that the solar system had finally found its 10th planet. But the excitement didn't last very long. Sedna's diameter, however interesting, was soon reduced, and the count of the planets returned to be the same as before. Only 517 days passed, and on July 29, 2005, still Mike Brown announced the discovery of another large object, provisionally designated 2003 UB313. The estimated diameter was even 2,400 kilometers larger than Pluto's, and at that point, it seemed evident that the newcomer had all the qualifications to be crowned the 10th planet in the solar system, and the first one found beyond Pluto's orbit. Then it became known how the thing turned out. Not only was Eris, as it was later definitively called, never considered a planet, but Pluto also lost its planetary status, so that the planets, instead of increasing in number, even decreased from 9 to 8. Pluto, despite the downgrade, still remained on everyone's lips and in everyone's hearts, but Eris, having missed the train that would bring it notoriety, was soon almost forgotten, probably because it was considered just one of the many planetoids that would continue to be discovered in the Kuiper belt in the future. Wrong prediction. Since 2005, in fact, nothing remotely comparable has been found in those remote regions, and Eris is still to this day the 9th most massive object to revolve around the Sun, the largest ever discovered since 1847, when Triton, Neptune's great moon, was found. In our opinion, Eris, on the other hand, deserves much more attention than it has received so far. To find something even bigger, we'll probably have to go as far as the Oort Cloud, And perhaps even there we will not find an object more deserving of the title of planet. Let's keep its memory alive and get to know a little closer, shall we? Eris was discovered by astronomer Michael Brown and his colleague Chad Trujillo and David Rabinowitz on January 5, 2005, from images taken on October 21, 2003. Why the long delay? How come they didn't notice it sooner? Well, the reason is simple. The team had been systematically scanning the sky for the largest trans-Neptunian objects for several years, and had discovered several of them such as Quaoar, Orcus, and Sedna, for example using automatic search software that analyzed all the images taken. This dramatically accelerated the process of object discovery and allowed them to cover a wider region of the sky with their survey. However, the team had decided to have the software exclude all objects moving at an angular speed greater than 1.5 arcseconds per hour, not compatible with their presumed distance. To get an idea of how small such a shift is, keep in mind that the angular diameter of the moon is about 1800 arcseconds. But after manually discovering Sedna, a decidedly slow-moving object, Brown and his colleagues realized that the software would ignore its presence, so they decided to reanalyze all the images they had collected over the preceding months. And it was only in this way that they were able to find the object that would later become Eris, a trans-Neptunian that moved very slowly relative to the background stars and had thus been ignored during the first phase of analysis. The discovery was announced on July 29, 2005, the same day as Makemake's discovery, and only 2 days after Haumea's. Further observations were then made to determine the preliminary orbit of Eris, and on September 10, 2005, a subsequent analysis with the 10-meter Keck telescope in Hawaii also revealed the presence of a satellite later named Haumea. Haumea is about 700 kilometers in diameter, making it the second largest of the dwarf planet moons after Pluto's Charon, and it orbits Eris in nearly 16 days at a distance of 37,000 kilometers. At that point, Brown was holding an object of considerable diameter, accompanied even by a large moon. It seemed that nothing could stop Eris from finally claiming the title of 10th planet. But instead, all hell broke loose, and its discovery basically marked the beginning of the end for Pluto as well. During 2006, very sadly, Pluto and Eris were given the consolidatory title of dwarf planet, a category that now also includes Ceres, Haumea, and Makemake. The orbit, very eccentric and inclined. Eris orbits the Sun in a very elliptical orbit with an orbital period of 559 years. In fact, its maximum distance from the Sun at aphelion is 98 AU, while its maximum at perihelion is only 38 AU. As it orbits the Sun, it completes one rotation every 25.9 hours. In the past, Eris arrived at perihelion around the year 1699 and at aphelion around 1977. In the future, it will return to perihelion around December 2257. Unlike the 8 planets whose orbits all lie roughly in the same plane as Earth's, Eris's orbit is highly inclined, about 44 degrees. This is why, despite its fair brightness, it has never been sighted before 2003. In fact, searches for large outer solar system objects tend to focus on the plane of the ecliptic, where most celestial bodies lie. Currently, Eris is the most distant object known in our solar system, if we disregard long-period comets. In theory, the detached object Sedna, which we met with discussing trans-Neptunian objects, is farther away from the Sun, having a semi-major axis of about 524 AU. However, currently Sedna is moving along a part of its orbit closer to the Sun at 84 AU and will arrive at perihelion around 2075-2076. Due to the high inclination of its orbit, Eris crosses only a few constellations of the traditional zodiac and is now in the constellation of Ceres. Size matters. Since its discovery, Eris's diameter has been gradually refined and reduced. In 2003, considering images of the Hubble Space Telescope, Eris's diameter was estimated to be 2,397 kilometers. For this, the classical approach of using distance to Eris, its albedo, and its apparent brightness was used. Albedo is a term in astronomy for the reflective power of a celestial body's surface. The maximum albedo is 1, when all incident light is reflected. The maximum albedo is 0 when no fraction of the light is reflected. The first case is that of a perfectly white object, the other of a perfectly black object. Eris has an estimated albedo of 0.96, higher than any other large body in the solar system except Saturn's 6th largest moon, Enceladus. Such high reflectivity is hypothesized to be due to surface ices, which are on the rise when, as at this time, Eris is in an orbital position far from the Sun. Comparing the diameter of Eris with that of Pluto, which at the time was estimated at 2,370 kilometers, Eris appeared to be slightly larger than Pluto, considering the best case of tolerances. It is very difficult to say which object is larger, Pluto or Eris. Pluto's atmosphere further complicates this assessment, which interferes with measurements of its solid surface. In 2007, the Spitzer Space Telescope was used to refine the dwarf planet's diameter, and the measurements indicated a diameter of 2,600 kilometers. In 2010, a rare event occurred, a stellar occultation. Never before had an occultation for such a distant object in our solar system been observed. The results cast serious doubts on previous measurements, in particular those of the Spitzer Space Telescope. Data obtained from the occultation during which Eris passed in front of a star indicated a diameter of only 2,326 kilometers. By contrast, in 2015, the New Horizons probe accurately measured Pluto's diameter to 2,376 kilometers. At present, then, barring other adjustments that are always possible, Pluto is confirmed as the largest dwarf planet, albeit by a very small margin compared to Eris. But mass also matters. Determining the mass of an isolated object like Eris with sufficient approximation is definitely difficult. Fortunately, the discovery of dysnomia has solved the problem at its root. In astronomy, it is indeed sufficient to know the orbital period of a satellite and its distance from the parent planet to easily determine the mass of the latter through Kepler's third law. A simple calculation then made it possible to find that the mass of Eris is 27% greater than that of Pluto, from which it followed that the density of Eris must be greater than that of Pluto. In fact, if we take into account the diameter determined during the stellar occultation, we obtain for Eris a density of 2.5 grams per cubic centimeter, significantly higher than Pluto's density of 1.75 grams per cubic centimeter. For comparison, the density of water is 1, while the average density of our planet is 5.5. Pluto and Eris therefore seem to have similar sizes but different densities. Their composition must therefore have been somewhat different. Eris is probably composed of much rockier and denser material than Pluto. Some astronomers suggest a composition of about 70% rock and 30% ice, but of course, these are only guesses. The surface and the atmosphere. The temperature of the surface as a result of a distance from the Sun that can vary considerably varies between minus 240 degrees and minus 216 degrees Celsius. No surface features can be observed directly from Earth, regardless of whether the telescopes are on the ground or in space. To know more, it is therefore necessary to proceed with indirect measurements, such as spectral analysis. On January 25, 2005, spectra were obtained at the 8 meters Gemini North Telescope in Hawaii. An analysis of the infrared spectrum revealed the presence of methane on the surface. Further analysis indicated abundances of carbon monoxide and nitrogen. This is similar to Pluto. When Eris approaches its perihelion, sublimation processes will be enforced, causing gases to escape from the surface and forming a thin atmosphere. Then, when Eris is departing from its perihelion, the surface temperature will continuously decrease until it reaches its maximum at the aphelion. The falling temperatures will enable resublimation, i.e., the gases in the atmosphere will freeze out and fall back onto the surface. Sublimation processes may be possible at these temperatures as methane is highly volatile. This, however, raises another question. How can we explain the observed abundances of methane if it is so volatile and sublimation can occur? Two possibilities are conceivable. First, Eris has always resided at such large distances to the Sun where it is cold enough not to trigger sublimation. Secondly, there may be an internal source for methane which replenishes the gas escaping the surface. No further details are known about Eris's surface. We can only observe that its color is different from Pluto and Triton. Whereas Pluto and Triton show a reddish color, Eris appears to be simply gray like many other objects in the Kuiper belt. Future research. The extreme distance of Eris, which is the largest object that has not been visited by a spacecraft, combined with its small size, makes it difficult to observe the dwarf planet without powerful telescopes and advanced technology. One real possibility which could come to fruition soon is that Eris could be observed by the James Webb Space Telescope, which is expected to enter its operational phase soon. Regarding exploration by probes, in the 2010s there were multiple studies for follow-on missions to explore the Kuiper belt, among which Eris was evaluated as a candidate. It was calculated that a flyby mission to Eris would take 25 years using a Jupiter gravity assist, based on launch dates of April 3, 2032 or April 7, 2044. Eris would be 92 or 90 AU from the Sun when the spacecraft arrives. But for now, these are just projects. To this day, Eris is still a distant dream for us, and probably it will still be for many years. Why the Makemake dwarf planet is special. On the outskirts of the solar system, in a region we know as the Kuiper belt, there are many small objects, including several dwarf planets. Makemake was the fourth discovered, and one of the reasons that Pluto lost its classification as a planet a decade ago. But what is so special about this object? Let's find out. A group of astronomers observed Makemake at the Palomar Observatory located in San Diego, California, in March of 2005. As a curiosity, the name of this object is pronounced like this, as it is written, as much as it may seem a repetition of the word make. 2 days earlier, the dwarf planet Haumea had been announced by a team of astronomers from Spain. This announcement was surrounded by controversy because it was made with data extracted from the computer of the Palomar Observatory telescope. This unfortunate event caused the Californian team to be forced to announce ahead of schedule the discovery of Makemake and Eris, for fear that they would try to snatch authorship again. Although Makemake has a relative brightness equivalent to 1/5 the brightness of Pluto, it was not discovered until after many other Kuiper belt objects with a fainter apparent magnitude. What happened is that the search for minor planets is done near the ecliptic, an area where most of the objects orbiting the Sun are located, while Makemake's orbit is very inclined. Ironically, Makemake has a very inclined orbit. At the time of its discovery, it was situated at its most significant distance from the ecliptic, in the north of the constellation Berenice's Hare. Although initially classified as 2005 FY9, in July of 2008 it was renamed Makemake. This name corresponds to the god of fertility in the mythology of the Rapa Nui, the inhabitants of Easter Island located southeast of the Pacific Ocean. Makemake was the chief god, humanity's creator, and fertility god. This object was discovered by the team led by scientist Michael Brown, the same one who discovered the dwarf planet Eris, and also participated in the discovery of the dwarf planet Haumea. Features of the dwarf planet. Currently, Makemake is the second brightest known object on the outskirts of the solar system, being only slightly darker than Pluto, and can be observed with a good amateur telescope. It has a diameter of 1,400 kilometers, 2/3 of Pluto, and its orbit is somewhat farther away. Still, it is closer than Eris, since while Eris completes a lap of the Sun every 558 years, Makemake takes 310 years to complete one lap around the Sun. It rotates on itself every 22.5 hours. It has a slightly shorter day than Earth's, and at its perihelion, it approaches 38 times the distance between the Earth and our star. At the same time, in its aphelion, it goes up to 53 astronomical units, has a somewhat eccentric orbit. Makemake stands out for its reddish-brown color, which led scientists to conclude that it must contain a layer of methane on its surface, probably in minor accumulations of 1 centimeter thick. Frozen ethane and nitrogen signals have also been detected on its surface. On April 23, 2011, Makemake passed in front of an 18th magnitude star and abruptly blocked its light, taking advantage of the planet's passage in front of the star. a phenomenon we know as occultation. This is somewhat surprising because Makemake has many similarities with Pluto. The difference is that Pluto does have a thin atmosphere. Astronomers also use that same moment to determine how much light the planet reflects. It is similar to the reflective capacity of dirty snow, making it somewhat dimmer than Pluto but brighter than Eris. The presence of methane and possibly nitrogen suggests that Makemake could have a transient atmosphere similar to Pluto near its perihelion. Perihelion is when the planetoid is closest to the Sun. If there is nitrogen on its surface, this will be its dominant component. The existence of an atmosphere also provides a natural explanation for nitrogen depletion. Because Makemake's gravity is weaker than that of Pluto, Eris, and Triton, a large amount of nitrogen was likely lost through atmospheric escape. Methane is lighter than nitrogen but has a vapor pressure significantly lower than the prevailing surface temperatures of Makemake, which are around -402.07 Fahrenheit. However, studies of Pluto's atmosphere by New Horizons suggest that the dominant exhaust gas is methane, not nitrogen. Therefore, the reasons for the absence of nitrogen in Makemake are still challenging to explain. Astronomers also found evidence of tholins on Makemake's surface. Tholins are molecules that form anywhere ultraviolet light from the Sun interacts with substances such as ethane and methane. If tholins are present, they usually cause a red-brownish color. This reddish color was seen during the observations of Makemake. Thanks to that, we know that the planet has a dark reddish color, similar to that of Mars, but without ice caps or significant rocky elevations such as mountains or volcanoes. But it must be covered with impact craters, since it does not have a geological system that renews its surface. As for its relief, it must look a lot like the dark side of the Moon, a place with many craters but on a reddish surface. However, this object is so far away that all this is only a hypothesis, since it has never been photographed with cameras aboard exploration probes as done with Pluto. Small, but with moon. In 2016, a team of astronomers reviewed Hubble Space Telescope observations captured in April 2016, and it announced the discovery of a satellite about 175 kilometers in diameter orbiting Makemake at a distance of approximately 21,000 kilometers and a period of about 12.4 days. This object was baptized as MK2. By the images of the Hubble telescope, it seems to be as dark as coal, something that is very striking for how bright the surface of its host Makemake is. And that could be explained because the gravity of the satellite is too weak to retain any ice, which sublimates from the surface of MK2 into space. Its finding is beneficial because it will allow us to study Makemake in more detail. It also helps us understand the nature of dwarf planets better and determine if the presence of satellites around them is uncommon or not. In future observations, astronomers also hope to determine MK2's orbit type. If it is circular, it would mean that the origin of the satellite is probably an impact that happened a long time ago, in precisely the same way that Pluto's satellites were created. Conversely, if it has an elliptical orbit, it would indicate that MK2 was a free-moving object in the Kuiper belt that Makemake captured. Makemake habitability. The temperature on Makemake is usually around -406 degrees Fahrenheit. Life as we know it cannot exist in such cold places, so this object is one of the places where it is 100% certain that we will not find any form of life. Plans for Makemake. From recent calculations with current technology, it is estimated that a flyby mission to Makemake could take approximately 16 years with the help of Jupiter's gravitational assistance. Based on a launch date of 2024 or 2036, Makemake would be about 52 AU from the Sun when the spacecraft arrives. However, there are still no expeditions established for Makemake, although its mystery and our lack of information about it is undoubtedly a strong point for a future expedition and continuous observation. For now, Makemake has no scientific interest since it cannot house water and living beings and does not have enough gravity to retain an atmosphere. So we will have to wait a long time to know more about this distant world in the far reaches of the solar system. Haumea, the strangest dwarf planet of all. This is one of the strangest objects in the solar system. It's classified as a dwarf planet, but it's not round. It has a ring of asteroids like Saturn's, but not as visible. Despite being very small, it has 2 moons. It has a flattened shape that gives it the appearance of an egg and spins faster than any other object in the solar system. This is Haumea, the strangest dwarf planet of all. Would you like to know why astronomers are so intrigued by this object? Let's find out. Haumea is a dwarf planet that lies in the Kuiper belt, a region of icy donut-shaped bodies beyond the orbit of Neptune, much like the asteroid belt between Mars and Jupiter, but farther from the Sun. For that reason, all objects in that place are icy and often covered in ice. Objects like Haumea that lie beyond the orbit of Neptune are classified as trans-Neptunian objects. These are very difficult to study due to their small size, low brightness, and enormous distances that separate us from them. The image we show at the beginning of the video is only an artistic representation of Haumea. Today we have not yet managed to photograph this object in a high resolution because no probe has ever been sent to explore it closely, just like it was done with Pluto. In 2003, the New Horizons probe managed to photograph the dwarf planet Pluto, showing white and dark colors with a surface covered with impact craters. Haumea has characteristics very similar to Pluto. Both are at similar distances from the Sun, and studies indicate that they are composed of very similar materials. With all that information, the artistic images we currently have of Haumea have been elaborated, but in practice, even with our most powerful telescopes, Haumea is seen as a point of light orbited by 2 other more minor points. With a radius of about 385 miles or 620 kilometers, Haumea is about 1/114th the radius of Earth. In addition, it is 43 astronomical units from the Sun. From this distance, it takes 6 hours for sunlight traveling from the Sun to Haumea. Measurements of its orbital velocity indicate that Haumea takes 285 Earth years to go around the Sun. However, it has an eccentric period. In its journey around the Sun, it moves far away and then gets very close. At its closest point, it approaches the Sun more than Pluto. An irregular shape. Haumea is a curious object. It revolves around the Sun in an elliptical orbit that takes 284 years to complete. It is currently about 50 times the distance between the Earth and the Sun from us. And its rotation speed is 3.9 hours, much faster than any other body over 100 kilometers in the entire solar system. When observed through a telescope, it looks like a point of light moving through the entire background of stars. However, it shows large fluctuations in brightness over 3.9 hours. One of the explanations for this phenomena is that there was some other body orbiting around it that hid its light from us, just like exoplanets do when they block the light from their star as it passes right in front of us. However, after many analyses of Haumea's brightness dips, scientists concluded that the dip in brightness could not be due to another object orbiting around it, but rather to the object having a rotation period lasting precisely 3.9 hours. This is faster than any known equilibrium body in the solar system and, in fact, faster than any other known body over 100 kilometers in diameter. While most rotating bodies in equilibrium flatten into oblate spheroids, Haumea rotates so rapidly that it is distorted into a triaxial ellipsoid. If Haumea spun much faster, it would be distorted into a dumbbell shape and split into 2 objects. It is believed that this rapid rotation was caused by the impact that created its satellites. Images captured with telescopes indicate that Haumea is as bright as snow. 80% of Haumea's surface appears to be pure crystalline ice, with a contributor to the high albedo that could be oxygen cyanide or phyllosilicatic clays. Inorganic cyanide salts such as potassium or copper cyanide may also be present. In 2005, the Gemini and Keck telescopes could independently obtain Haumea's light spectrum, which shows large numbers of ice crystals similar to that seen on the surface of Pluto's moon Charon. Further studies of the visible and near-infrared spectra suggest a homogeneous surface covered by a 1-to-1 mixture of amorphous and crystalline ice and 8% organic compounds. This is unusual for an object, as crystalline ice forms at more than 100 to 110 K. However, the surface temperature of Haumea is less than 50 K, which is thermodynamically more favorable for amorphous ice formation. Then for crystalline ice to form, there must have been an increase in temperature, either by collisions that heated the surface layers or by the heat emanating from the interior of the planetoid. Moons on a dwarf planet. On January 6, 2005, the WM-Keck Observatory discovered a natural satellite orbiting Haumea. An interesting fact is that initially the team of astronomer Michael Brown, who had been involved in the discovery of Haumea, called the planetoid Santa because they discovered it on December 28th. For that reason, the satellite discovered in 2005 was given the provisional name of Rudolph, an allusion to the central reindeer of Santa Claus. The satellite was later named 136108 Haumea, Hianka. It is the outermost, most significant and brightest satellite of Haumea, about 310 kilometers in diameter. It orbits in a nearly circular trajectory with a translation period of 49 days at a distance of 50,000 kilometers. Its absorption characteristics in the infrared spectrum are consistent with its surface being covered mainly with almost pure crystalline ice. The satellite's unusual light spectrum plus absorption lines similar to those of Haumea led a Caltech team to conclude that the moons must be fragments of the dwarf planet itself, so that they would have arisen from a collision millions of years ago. Later in the same year, on June 30th, a new satellite was discovered and given the provisional name of Blitzen, later renamed 136108 Haumea 2 Namaka. It is the most miniature satellite and closest to Haumea. It has a highly elliptical orbit, which travels in 18 days, and according to measurements made in 2008, it tilts 13 degrees concerning the plane of the orbit of the largest satellite, which disturbs its own. The relatively large eccentricities and mutual inclination of satellite orbits are unexpected, as tidal effects should have dampened them. Isn't alone. Haumea is the most prominent member of the collisional family that bears its name. A collisional family is a group of astronomical objects with similar physical and orbital characteristics that could have had a common origin. There are several theories about the origin of this collisional family. Astronomer Michael Brown, a pioneer in discovering dwarf planets, proposed that it is formed due to the direct impact that tore away the Haumea ice sheet. Another hypothesis, based on a high-speed collision, suggests that the material ejected in the initial collision merged into a large Haumea moon, which was later destroyed in a second collision, scattering its fragments outward. However, the Kuiper belt is very unpopulated, so the chance of a collision in the ancient solar system is less than 0.1%. The Haumea collisional family could not have formed in the primordial, denser Kuiper belt because such a tight-knit group would have been altered by Neptune's migration within the belt, which is thought to be the cause of the low current density of the Kuiper belt. Therefore, it is suggested that the origin of the object that collided with Haumea and its relatives lie in the dynamic region of the scattered disk, in which the possibility of such a collision is much higher. A dwarf planet with rings. Although Saturn is the planet with the largest and most colorful asteroid rings, in reality, Jupiter, Uranus, and Neptune also have asteroid rings. The difference is that these are only visible with infrared cameras, since their rings are very faint in visible light. One of the most exciting and unexpected finds on the dwarf planet Haumea is discovering a ring of asteroids around it. Until just a few years ago, we only knew about the existence of rings around giant planets. Recently discovered that two small bodies between Jupiter and Neptune, belonging to the family of objects called centaurs, have rings. Now have discovered that bodies even farther away than centaurs, more extensive and with very different characteristics, can also have rings. The first of them to be discovered is Haumea. According to the data obtained from the occultation, the ring is in the equatorial plane of the dwarf planet. It shows a 3-to-1 resonance concerning the rotation of Haumea, which means that the icy particles that make up the ring complete a spin around the planet in the time in which it rotates 3 times on itself. There are several possible explanations for the formation of Haumea's asteroid ring. For example, it could have originated after a collision with another object or by releasing some of the surface material due to the rapid rotation of Haumea. This is the first finding of a ring around a trans-Neptunian object and shows that the presence of rings could be much more common than previously believed, both in our solar system and other planetary systems. Thanks to all this information, we know that Haumea is one of the strangest objects in the solar system. Even temperature analysis on its surface indicates that the speed of rotation of the planetoid could generate large amounts of friction inside, which would eventually produce heat, and this would melt the ice, turning it into water. Is it possible that there is water in Haumea? Most scientists think not, since it is too far from the Sun. However, many astronomers do not rule out the possibility. Gonggong, the ice-cold dwarf planet you've never heard of. What if I told you there's a mysterious planet in our solar system way beyond Neptune that's smaller than our moon, but has a moon of its own? Imagine a world so far away it takes 554 Earth years to complete just one orbit around the Sun. That's Gonggong, a dwarf planet that breaks all the rules. If you thought Pluto was icy, wait until you see Gonggong, one of the coldest places in the solar system, which to scientists' amazement is actually red. Most people are still in the dark about the true wonders of this fascinating planet. Unlike Pluto, which takes about 248 years to orbit the Sun, Gonggong's orbit stretches over 554 Earth years. Although it's smaller than Earth's moon, Gonggong has its own moon, Xiangliu, and an icy surface that makes it one of the coldest places in the solar system. But the story of Gonggong gets more intriguing and mysterious when we consider its unique surface composition, appearance, and strange location in the Kuiper belt. Keep watching as we explore this fascinating world and why it's not usually mentioned alongside the 5 IAU-recognized dwarf planets, Ceres, Pluto, Haumea, Makemake, and Eris. But to begin, let's provide some important context. Unless you're watching this from space, you're currently on a planet, essentially a massive sphere of material and heat. When we zoom out into space, we see Earth and 3 other rocky inner planets. As we move farther from the Sun, we encounter 4 large gas giants, mostly made of hydrogen and helium. Together, these 8 planets make up our solar system: 4 rocky terrestrial planets and 4 gas giants. However, this is just part of the story. Beyond the orbits of these major planets, there are numerous small, icy worlds scattered throughout the outer reaches of the solar system. Among these distant icy worlds is Gonggong, officially designated as 2007 OR10. On July 17, 2007, American astronomers Megan Schwab, Michael Brown, and David Rabinowitz made a groundbreaking discovery, finding the dwarf planet Gonggong as part of the Palomar Distant Solar System Survey. The survey, conducted using the Samuel Oskin telescope at Palomar Observatory near San Diego, California, aimed to find distant objects in the region of Sedna, beyond 50 AU from the Sun. This fascinating dwarf planet resides far beyond Neptune, in a region of space known as the scattered disk. Its orbit takes it well beyond the orbit of Neptune, making it one of the most remote objects we know of in the solar system. To put things in perspective, Gonggong orbits the Sun at an average distance of about 67 times farther than Earth. Imagine being so distant from the Sun that your planet receives only a tiny fraction of the sunlight Earth does. Gonggong's distance from the Sun is not just a fun fact. It has profound implications for its characteristics and the way it moves through space. Its journey around the Sun is incredibly slow compared to Earth's. This slow orbit contributes to its extreme temperatures and the length of its year, making it a striking contrast to the familiar cycles we experience on Earth. Now let's consider Gonggong's size. It measures about 1,230 kilometers in diameter, making it one of the largest known trans-Neptunian objects discovered so far. To put that into perspective, it's significantly smaller than Earth's moon, which has a diameter of approximately 3,474 kilometers. Despite its smaller size compared to our moon, Gonggong still holds its place as a sizable and important object in our solar system's outer reaches. Gonggong's surface is primarily composed of ice, which reflects its location in the far reaches of space where temperatures are extremely low. This icy surface gives Gonggong a characteristic pale appearance, and scientists later discovered that it has a reddish tint caused by organic compounds called tholins. These compounds form when sunlight interacts with the icy surface, creating a kind of cosmic paint that adds to Gonggong's unique look. Gonggong is also intriguing because of its rotation. It has a very slow rotation period, which means that a single day on Gonggong takes about 22 hours to complete. This slow spin is quite unusual for distant objects like Gonggong and adds to the mystery of how it formed and evolved over time. In 2019, the team that discovered the distant object held an online poll to let the public choose a name for it. The finalists were Gonggong, the Chinese water god, Hall, the Germanic winter goddess, and Vili, a deity from Norse mythology. Each name was linked to themes of water, ice, snow, and the color red. Ultimately, Gonggong won the poll, chosen by popular vote, and the name was submitted to the IAU. In February of 2020, the Minor Planet Center of the IAU accepted the name and updated its catalog. This name, originating from Chinese mythology, honors Gonggong, a water deity, and marks the first time a planetary object has been named with a Chinese name. In terms of its environment, Gonggong is a stark contrast to Earth. While Earth is a vibrant, life-sustaining planet with a temperate climate, Gonggong is an icy world with extremely low temperatures. Its distance from the sun means that it receives very little sunlight, contributing to its icy surface and frigid conditions. This extreme cold makes Gonggong a world of contrasts compared to our own blue planet. An even more interesting aspect of this strange dwarf planet is its orbit. It follows a highly elliptical path around the sun, which means its distance from the sun changes significantly over the course of its orbit. This elliptical orbit also means that Gonggong's environment can vary, adding another layer of complexity to our understanding of its physical and orbital characteristics. Now, let's quickly look at the single moon of dwarf planet Gonggong in the Kuiper belt. What is Xiangliu, and what role does it play in shaping Gonggong's strange nature? In March of 2016, scientists found that Gonggong was rotating unusually slow, suggesting that a moon's gravitational forces might be slowing it down. This led Chaba Kiss and his team to examine older Hubble Space Telescope images of Gonggong. Their analysis of images from September 18, 2010 revealed a faint moon orbiting at least 15,000 kilometers or 9,300 miles away. The discovery was officially announced on October 17, 2016, though the moon had no provisional name at that time. They later identified Xiangliu in earlier Hubble images from November 9, 2009. Follow-up observations in 2017 helped estimate Xiangliu's brightness and provided more information about its orbit. Xiangliu is about 4.59 magnitudes dimmer than Gonggong and orbits between 20 and 100 days. More accurate data later placed its orbit at 25.22 days at a distance of around 24,021 kilometers or 14,926 miles. Xiangliu is thought to be tidally locked to Gonggong, meaning the same side always faces the dwarf planet. Because scientists have observed Xiangliu over only a small part of Gonggong's orbit around the Sun, they still can't tell if its orbit is prograde or retrograde. If Xiangliu's orbit is prograde, it's inclined by about 83 degrees to the ecliptic, suggesting that Gonggong is viewed nearly pole-on. The orbit is highly eccentric, oval-shaped with an eccentricity value of 0.29, which could have been caused by tidal wave forces or Gonggong's irregular shape. Xiangliu's dynamics are similar to Quaoar's moon, Weywot, which also has a moderately eccentric orbit. The moon was named after the nine-headed venomous snake in Chinese mythology, Xiangliu, who served the water god Gonggong and was known for causing floods and destruction. Now, let's briefly look at the brightness of the dwarf planet. With an absolute magnitude, H, of 2.34, Gonggong ranks as the seventh brightest known trans-Neptunian object, falling between Orcus and Quaoar in terms of brightness. However, estimates from the Minor Planet Center and the Jet Propulsion Laboratory Small Body Database suggest that Gonggong's absolute magnitude could be as high as 1.6 or 1.8, which would propel it to fifth place among the brightest trans-Neptunian objects. At a distance of 88 AU from the Sun, Gonggong's apparent magnitude is a faint 21.5, making it impossible to spot with the naked eye from Earth. Despite being closer to the Sun than the dwarf planet Eris, Gonggong appears dimmer due to its lower albedo, whereas Eris shines with an apparent magnitude of 18.8. What's next for the exploration of Gonggong and other Kuiper Belt objects? The Kuiper Belt is a trove of scientific discoveries. The discovery and evaluation of Kuiper Belt objects, KBOs, also referred to as trans-Neptunian objects or TNOs, have contributed to a renewed understanding of the solar system's past. Despite the progress in astronomy and robotic explorers, our understanding of the trans-Neptunian region and the Kuiper Belt is still limited. To date, the only mission to investigate Uranus, Neptune, and their significant moons was Voyager 2, which flew by these ice giants in 1986 and 1989. Furthermore, the New Horizons mission was the first spacecraft to explore Pluto and its moons in July of 2015, and the only one to meet a Kuiper Belt object, which occurred on January 1, 2019, when it passed by the KBO called Arrokoth. Researchers are now interested in using the JWST to examine these planetoids in the Kuiper Belt, Sedna, Gonggong, and Quaoar. A recent study by planetary scientist Amanda Zangari estimated that a flyby mission to Gonggong would take at least 20 years with current rocket technology. A flyby could take just under 25 years with a Jupiter gravity assist, assuming a launch around 2030 or 2031. Gonggong would be about 95 AU from the Sun when the spacecraft reaches it. Gonggong's distinctive traits make it an appealing target for upcoming space missions. Close-up study could yield invaluable knowledge about the solar system's creation and development. As technology evolves, we can expect more in-depth observations and possibly even a dedicated mission to this intriguing dwarf planet. Investigating dwarf planets like Gonggong is vital for enhancing our grasp of the solar system's origins and composition. Orcus, the anti-Pluto dwarf planet. In this video, we will deal with Orcus, a trans-Neptunian celestial body. As the adjective trans-Neptunian says, Orcus is a celestial body that is located beyond the orbit of Neptune in a portion of space known as the Kuiper Belt or Edgeworth Kuiper. The Kuiper Belt or Edgeworth Kuiper is an outer region of the solar system that extends from the orbit of planet Neptune, about 30 astronomical units from the Sun, up to 50 astronomical units from the Sun. Its overall shape is somewhat reminiscent of a donut. It takes its name from the astronomers Gerard Kuiper and Kenneth Edgeworth, who in a 1951 article hypothesized the presence of objects beyond Neptune's orbit, later known as trans-Neptunian objects or TNOs. Unlike the main asteroid belt between the orbits of Mars and Jupiter, essentially composed of rocky bodies, the Kuiper Belt is composed of small icy bodies, mainly water ice, ammonia, and methane, whose orbits are arranged on the plane of the ecliptic, which is the same plane on which the orbits of the planets also lie. Among the many celestial bodies of the Kuiper Belt, we find Orcus, discovered on February 17, 2004, by Michael E. Brown of the California Institute of Technology, Chad Trujillo of the Gemini Telescopes, and David Lincoln Rabinowitz of Yale University. But the celestial body was later identified in some photographic images in the archive dating back to December 8, 1951. Possessing a size and an orbit similar to that of Pluto, Orcus has been given the name of a deity of the underworld. In accordance with the astronomical naming conventions of the International Astronomical Union, the discoverers suggested the name Orcus, which was approved and published on November 22, 2004. Orcus is both an alternate name for the Greek deity Hades and an abstract god of the death in Roman mythology. Orcus is a large Plutino and takes 247 years to travel its orbit around the Sun. Although Orcus has an orbital period very similar to that of Pluto, it has a different orientation. Thanks to 1951 images from the Siding Spring Observatory in Australia and 1954 from Palomar Sky Survey, it was possible to determine that the distance of Orcus from the Sun varies between 30.9 astronomical units and 48.1 astronomical units. Orcus's orbit is inclined by 20.6 degrees on the ecliptic, more than that of Pluto, which is about 17 degrees. The last passage in aphelion of Orcus took place in 1989, while the next passage in perihelion will take place in 2113. Would you like to visit Orcus? Write it in the comments. Due to its 2 to 3 resonance with Neptune, Orcus and Pluto are in opposite positions. For this reason, Orcus is also known as the anti-Pluto. Every 14,000 years, Orcus comes within 18 astronomical units of Neptune. The apparent magnitude of the dwarf planet is equal to 19.1, which is roughly equivalent to that of 50,000 Quaoar. In any case, it is a value well below the threshold of visibility to the naked eye, which is around the 6th magnitude. Assuming an albedo of 0.09, Trujillo estimates its diameter to be approximately 1,600 kilometers. Recall that the albedo represents the fraction of incident solar radiation reflected from the surface of a celestial body in all directions. Orcus would therefore be among the largest objects in the Kuiper belt so far, along with Eris, Pluto, Makemake, Haumea, Sedna, and Gonggong. According to observations in the infrared band made by the 4 very large telescopes in Chile of the European Southern Observatory with a diameter of 8 meters, on the surface of Orcus there would be water ice and carbon residues. Observations made by the Hubble Space Telescope from November 13, 2005 onwards made it possible to discover a satellite orbiting around Orcus. The discovery was made by Mike Brown. The discovery of the Orcus satellite was reported by the International Astronomical Union on February 22, 2007. The satellite thus discovered was initially indicated with the provisional designation S2005-904821. Later, it was given the official designation of Vanth as the Etruscan deity of the underworld. Its orbit is nearly circular with an orbital eccentricity of 0.0036, an orbital period of 9.53 days, and a distance of just 8,980 plus or minus 20 kilometers from Orcus. It also has a spectrum very similar to Orcus, a characteristic that can determine its surface structure. In 2005, the satellite was estimated to be separated of 0.25 arcseconds from Orcus with a magnitude difference of 2.7 plus or minus 1. Assuming an albedo similar to that of the planet, the magnitude suggested a diameter of about 250 kilometers, equal to about 1/4 of the diameter of Orcus. Definition of Sedna. Planet Sedna is a distant and mysterious world located in the outer reaches of our solar system. It is the most distant known object in the solar system and has been classified as a dwarf planet. It was discovered in 2003 by Michael E. Brown, who later named it Sedna after the Inuit goddess of the sea, Sydney. Sedna is believed to be the remnant of the early solar system. Exactly 2 decades later, Sedna has again caught the limelight of astronomers all around the world. Due to its mysterious nature, Sedna has always confused astronomers until now. Sedna is a dwarf planet by the International Astronomical Union, IAU. It was officially classified as a dwarf planet in 2008, making it the 3rd object recognized by the IAU. It is located beyond the orbit of Neptune and is believed to be part of the Kuiper belt, a region of icy bodies beyond the orbit of Neptune. Overview of Sedna's discovery. The discovery of Sedna has significantly impacted the field of astronomy and astrophysics. Sedna is the most distant object ever observed in the solar system, and its discovery has provided scientists with valuable insights into the formation and evolution of the outer solar system. Sedna's discovery has also helped to confirm the existence of the hypothesized Oort Cloud, a vast spherical shell of icy objects that surrounds the solar system. Sedna's orbit is highly eccentric, and its perihelion is much farther from the Sun than any other known object in the solar system. This suggests Sedna is a member of the Oort Cloud, and its discovery has provided further evidence to support the hypothesis. Sedna's discovery has also led to the development of new theories about the formation of the solar system. Its highly eccentric orbit suggests that it may have been affected by the gravitational pull of a passing star, which could have caused it to be flung out to its current location. This has led to the hypothesis that the solar system may have been formed from the gravitational interaction of multiple stars. Now, this is where it gets interesting for astronomers. Sedna's bizarre behaviors may have risen due to various external factors. Sedna's discovery has also helped to shed light on the mysterious Planet 9. Its highly eccentric orbit is similar to that of other objects hypothesized to be part of Planet 9's gravitational influence. This suggests that Planet 9 may indeed exist, and its discovery could help to unlock the mysteries of the outer solar system. So many secrets trapped within the unknown knowledge of Sedna. Imagine if there was a space exploration of this dwarf. Such an event would immensely benefit astronomers in their fields of study. We started talking about Sedna all the way down to Planet 9 and the Sun's interaction with other stars. Let's restrict ourselves to Sedna for now. Planet 9 can wait for now. Physical characteristics. Sedna is a giant reddish-brown dwarf planet located in the Kuiper belt, beyond the orbit of Neptune. The surface of Sedna is believed to be composed of a mixture of water ice, methane ice, and tholins, which are organic compounds created by ultraviolet radiation. It is estimated to have a surface temperature of around -240 degrees Celsius. The surface is believed to be covered in craters, ridges, and other features, which are thought to have been created by impacts from other objects in the solar system. Its surface is covered in a thick layer of methane and nitrogen ice, which gives it its reddish-brown hue. Its atmosphere comprises a thin layer of methane, nitrogen, and carbon dioxide. It has a prolonged rotation period of about 20 days. Sedna's rotation is also a mystery. It is believed to be rotating very slowly, taking almost 10 days to complete one rotation, which is much slower than the other planets beyond Neptune. Also, its rotation is unsynchronized with its orbit. This suggests that it may have been affected by some external force, such as a passing star or another planet. Size and mass. It has a diameter of approximately 1,000 kilometers, around 3/4 the size of Pluto, making it the fourth largest known trans-Neptunian object. You may be wondering what trans-Neptunian objects are. Trans-Neptunian objects, TNOs, are small celestial bodies that orbit the Sun at a distance greater than Neptune. They are located in the Kuiper belt, a region of the solar system beyond the orbit of Neptune. TNOs include dwarf planets, comets, and other small bodies. Orbital path. The mysteries of Sedna are numerous and varied. For one, its orbit is highly unusual. It is one of the most distant objects in the solar system, and its orbital path is highly inclined to the plane of the solar system, which means that it is not in the same plane as the other planets. Its orbit is much more elongated than those of the other planets. Sedna is located in the Kuiper belt, a region beyond the orbit of Neptune that is home to many icy bodies. Its orbital path is highly elliptical, with a perihelion, closest approach to the Sun, of 76.1 astronomical units, and an aphelion, farthest distance from the Sun, of 937 astronomical units. It takes about 11,400 years for Sedna to complete one orbit around the Sun. Sedna's orbit is also vital for understanding the dynamics of the outer solar system and the possible presence of a giant, undiscovered planet beyond Neptune. Theories of origin. The origin of Sedna is also a mystery. It is believed to be a member of the Kuiper belt, a region of icy bodies beyond Neptune, but its exact origin is unknown. The Sun's gravity may have captured it, or it may have been formed in the outer solar system and then captured by the Sun. Some astronomers believe it is a dwarf planet, while others think it is a giant comet captured by the Sun's gravity. Still, others believe it is an escaped moon of Neptune that was ejected from the planet's orbit due to gravitational interactions with other objects in the outer solar system. Following are some theories predicting the origin of Sedna. 1. Capture theory. This theory suggests that Sedna was once part of a much larger body, such as a planetesimal or dwarf planet, which was captured by the gravitational pull of the Sun. 2. The capture and ejection theory suggests that Sedna was once part of a much larger body captured by the gravitational pull of a passing star. The star ejected Sedna from its orbit, sending it into the solar system's outer reaches. 3. The planet formation theory suggests that Sedna formed from the same cloud of gas and dust that constructed the other planets in the solar system. 4. The migration theory suggests that Sedna formed in the solar system's outer reaches and then migrated inward due to gravitational interactions with other objects in the solar system. 5. Capture from interstellar space theory. This theory suggests that Sedna was captured from interstellar space by the gravitational pull of the Sun. Composition. Sedna is a rocky core surrounded by a mantle of water ice. Is it impossible? At first thought, it seems to be, but space is mysterious. You know what they say, it is what it is. The center comprises silicate rocks such as olivine, pyroxene, and possibly some iron-nickel metal. The mantle is composed of a mixture of water ice, methane ice, and ammonia ice. Another mystery of Sedna is its composition. It is believed to be composed primarily of rock and ice, but its exact composition is unknown. Its reddish hue suggests that it may contain organic compounds, but this has yet to be confirmed. Potential for habitability. Sedna is located in the solar system's outer reaches and is too far from the Sun to be considered habitable. It is estimated to have a surface temperature of around -240 degrees Celsius, which is far too cold for any known life form to survive. Additionally, Sedna has no atmosphere and is exposed to extreme radiation levels, making it even less likely for any form of life to exist there. Despite its inhospitable environment, some scientists have suggested that there may be a subsurface ocean of liquid water on Sedna, potentially providing habitat for extremophiles. However, the conditions on Sedna are still too extreme for any known form of life to survive, and further research is needed to determine if the planet could potentially be habitable. But by creatures, we are referring to the large ones, the ones comparable to or more prominent than human beings. There still may be some tiny organisms which may survive Sedna's extremes easily. Impact of Sedna's discovery. Sedna is an intriguing and mysterious world still being studied by astronomers. Its unique orbit and composition make it an essential object for understanding the formation of the solar system. It is also of interest due to its unusual color, which may provide clues about the composition of the outer solar system. As we continue learning more about Sedna, it will undoubtedly remain an essential part of our understanding of the solar system. The mysteries of Sedna are likely to remain unsolved for some time. Its unusual orbit and composition make it a fascinating object to study, and its origin is likely to remain a mystery for many upcoming years. Nevertheless, the study of Sedna is likely to provide valuable insights into the formation and evolution of the outer solar system.